Good morning, dear students. Had your breakfast? What did you have? Shreya Varsha, what did you have for your breakfast? Today, what did you have, Rakshita? Today. Vishal? Okay. Someone said puri, right? Who said puri? What is the shape of that puri? Circle. What is the shape of that puliogra that you get? You said puliogra, right? What is the shape of the rice of those puliogras? Oval kind of thing. You said something, right, about avalaki. What is the shape of avalaki? Yes, it will be rounded edges with rectangle shape. What did you have for your breakfast? Idli. What is the shape of idli? Round shape. What did you have for idli? Same pitch. What did you have for your breakfast? Dosa. It's round shape. Ma'am, what did you have for your breakfast, ma'am? Palau. So, all of you have had your breakfast, and you can observe that the material that we eat are made of different shapes. Some said idli is made of round, dosa is made of round shape, puliogra is made of oval shape, that is the rice. So these are basically called as geometrical figures. So those are things that we are going to study today. Next. So there are many other concepts that are there in geometry, but I will take the point, line, segment and line. So those are the three concepts that we are going to take for today's discussion. So first we will understand what is meant by geometry. When I say the word geometry, let me break it into two parts, geo and metron. Geo means, hello guys. So when I say the word geometry, it is made up of two words, geo and metron. Geo means earth, metron means measurement. So in the initial days of geometry, which was founded by Euclid, one of the famous physicist, mathematician, philosopher. So he was the founder of geometry, and he said about the measurements of different things or different materials that were found on Earth. So finally, that particular branch of mathematics which was dealing with the measurements was given the name geometry. Hence we can say that geometry is a branch of mathematics which deals with measurements. So it deals with the various properties of geometrical figures like points, lines and angles. So we will go in detail and see what are the things they are. So first we go to the point. A point determines the location. So if you are going to any other place, if you don't know the route, what you will use in your mobile? Google Map. It will show the route. It will show the distance. For example, every day we will be going to Malsatan school. The first day when we were going, we didn't know the route. At that point of what we did, we were going on scooty and we were just going near the CBT and we just stood there. We just opened the map and we searched the Malsatan school. It shows the road. How it is showing the exact location? It is based on the latitude and longitudes. The earth is divided into many longitudes and latitudes. So every point on earth it is bifurcated and they are in specific location based on the degrees. So if, for example, if I am standing here in this particular location, then let me consider this hall as a 3D figure. This entire hall is a 3D figure. So let me consider this as x-axis, this as y-axis, and this as z-axis. So all three are lying perpendicular to each other. Now if I am standing here, then I am at certain x distance from the x-axis, certain y distance from the y-axis, and also if my height is at a certain height from the ground. That is, it is a particular distance from the z-axis, along the z-axis. So I can say that my head, this particular head, is located at a particular coordinate x, y, z. Say 10 centimeter, how much it is? 1 meter from x-axis, 2 meters from y-axis, and 1 meter from z-axis. I can write the location 1, 2, again 1, 1 to 1. So this is the coordinate. So point is used to determine the location. So if I put a point in any plane or any 3D figure, then I will be able to find the location of that point. So that's the reason we always use point for determination of the location. The second point, these are the examples we got: pencil tip, needle, and compass. Next. So you can see that we got the pencil tip. It is so sharp. As soon as I just bring the pencil tip and just place it on a piece of paper, what will happen? There is a impression. A black dot has appeared on the paper. So that is basically the point. We can observe the tip of this needle is Suji. So you can see it is a pointed shape. So it will leave a small impression on the paper or cloth, whatever. In a similar fashion, where do you use it? In geometrical box, right? It is a compass. It is used to draw the circles. So we will just insert a pencil like this, and we will start. We will just place it as a. We will put this arm as a fixed point, and we will just rotate the pencil so that we can get a circle. So also you can see that there is a sharp tip at this point. So it is a compass. Next. So these are basically 3 examples for point. Now we will understand what we mean by line segment. Before understanding line segment, it's also very important to understand what do you mean by segment. Segment means a section. For example, recently one famous serial got concluded. What was that? It was having CD. Sitaram, right? So recently it got concluded in Zee. So we could see that there was a section. Every day 5:30 to 6 p.m. Initially it was at night, then they shifted it to 5:30 to 6. So there was a particular slot, particular segment that was there. Every day half an hour. Not more, not less. There was a segment, 5:30 to 6. That was a particular segment. That was a upper limit, there was a lower limit. There was a segment that was allotted to that particular serial. In a similar fashion, for a line which doesn't have any boundary, which doesn't have any limit. So what we are going to do, we have to put a limit. We are going to put a boundary. When we put a boundary, then we get a line segment. So segment is nothing but a section. When we are putting the same restriction on a line, then it becomes a line segment. So we can say the line which has got fixed distance. Say the line may be of 10 meter, 20 meter, 30 meter, any line. For example, this is itself a line segment. It is not extending for a longer distance. It is having a fixed length. Say how much it is? 30 centimeter scale. So it is approximately 30 centimeter. It has got a fixed length. If I take the length of this bench, approximately it is 1.4 meter. So it has got a particular fixed length. So we can say that AB is a line segment. So you can see the examples of the line segment. So the tube-head, the length of this tube-head is around 1 meter somewhat, a particular length. It is not extending, it has got a fixed length. The famous chocolate box, right, diamond ring. So if you look at the corner of this diamond ring box, you will see that it is of a fixed length. That there is a line, but it is restricted to a particular distance. So you can see it as a line segment. The third one, which we don't use nowadays, so it's almost gone. We are using WhatsApp and other messengers. But in the postcard, you can see that the length of this postcard, the breadth of this postcard, all are having particular fixed length. So we can say that as also as we can give them as an example of line segment. So these are the 3 basic examples for line segment. Come in. So next. Then now we will go into the line. Line is a geometrical figure which doesn't have any boundaries. It can be extended on both sides endlessly. So I have written it can be extended infinitely on both sides. Here A point, B point. important. So if I just take AB, then it becomes a line segment. And if I extend this line on both sides, along A, along B, then what happens? It becomes a line. If there any line, it doesn't have any limit, it doesn't have any boundary, then we say it as a line. If it has got a boundary, then what we will say it as line segment. Yes. Next. So you can see the equator of Earth. The Earth is rotating on its axis. You can see that equator is constantly running. There is no fixed length for equator. It is constantly going on, going on, going on. So that is an example for line. The highway. If I start from Dharwad to Bangalore, it will run away, it will run away. After reaching Bangalore, it will not stop. Again next part. So it will be constantly going, it will never stop. So those are some of the real life examples for line. So these are then we come up with something called as intersecting lines. When I say the word intersecting, what comes to your mind? Intersecting. Yes. X, something which will meet each other. Yes, exactly. So intersecting lines. So you all three come from a hostel itself, right? Or you come from different places? From hostel. Do you live in the same place or from different places? Same place. Vaishnavi, from where do you come? Where is your home? Saraswati. Where is your home? Vidyayi. Udayagiri. So you all people coming from different places, you are coming and amalgamation is happening over there. So you all are coming and meeting at a particular point called JSS. Hundreds of people of B.Ed first year students, they are coming from different places. I am coming from somewhere, he is coming from somewhere. Where are you coming from? Don't tell me from outside. Where is your place? Home? Where is your home located? Gandhinagar. Where is your home located? Shettalpalli. So we all 9 members, we are coming from different places, and exactly at 9:30 we will be meeting at one student school. So that is the intersecting point. So in a single fashion, these are the lines, different lines coming from different paths, different places, and they are meeting at a single point. So this is the intersecting point. So such lines are called as intersecting lines. The lines which come from different places and meet at a single point. Yes, exactly. So which meet at a single point. Such lines are called as intersecting lines. So here I got line 1, I got line 2. We have even multiple lines. Fine. So these two lines, they intersect at only one point. They are intersecting at only one point. Such lines are called as intersecting lines. Next. The examples for these are the crisscross roads. Very often we find this kind of roads when we are going for different like tourist places, or when we want to go to any devotees. At that point of what? Yes. Whenever we are going for a travel, we do observe this kind of roads. So two different roads, they come and meet at a particular point. That's a junction. So initially, if it is in a local area, then we will be having traffic signals, right? So that is the example for intersecting lines. One line, the other line. They are coming and meeting at a particular point. The similar line in scissor also you can see. There is one line and the other line. They are coming and intersecting at a particular point. The screw is holding those two different lines at a single point. So that is also an intersecting point. In the similar fashion, the alphabet text that we write every day when we are writing. So we always write in a cross fashion. So you can observe that one line, the other line, they intersect at a particular point. So this is an intersecting line. So we can say these two lines are intersecting lines. Do you have any doubt till know what I have taught? Do you have any doubt, any confusion? Can I move forward? Then we go to the parallel lines. Parallel lines are those lines which never meet each other. They are together with each other, but they will never meet each other. It's like that. It's like that. These lines, they never meet each other at any point. So this is one line, maybe. We got the other line, C. They never meet each other. They are having constant distance. Say the distance between these two lines at this point, point A, if it is say 10 centimeter, here also it will be the 10 centimeter. That the distance between there will be a fixed distance between those two lines. Such lines are called as parallel lines. So when I was in my 7th or 8th, I used to always get confusion between parallel lines and perpendicular lines. Whenever they used to ask what do you mean by parallel lines, I used to write the lines which meet at 90 degrees, I used to write parallel lines. Whenever they used to ask me what do you mean by perpendicular lines, I used to write the lines which never meet are perpendicular lines. Because I was not having that visualization with the concept. Then I found a shortcut for it. How I remember is, so I started writing this parallel, LL, they are parallel, they will never meet. So I took that as a trick. So whenever I will write parallel, I will be knowing, okay, LL are not meeting each other. That means, so those are always running parallel to each other. If it is parallel, then the other way it will be perpendicular. So in this manner, I have remembered this. So this is a basic mathematical representation to represent how the AB is a parallel to CD. So if I write like this, the two lines, then it will represent that AB and CD are parallel lines. Next. So these are the examples, real life examples for parallel lines. So one railway track, the other railway track, they will never meet each other. Will they meet? If the railway track meet, then the train will not meet its destination. It's as simple as that. What? Move again. Akasmat available kudidra mugite train adar dari muttambula. So that is one of the example for parallel lines. The second example is the running tracks in athletics, the Olympics or the Asian Games, Commonwealth Games, wherever you see, you see that the tracks are always parallel. They never intersect each other. Whenever they are bending, definitely there will be some crisscross. Definitely they will be there. But when I am talking about 100 meter space, then they will never meet. There will be a parallel will be there. In a similar fashion, the highway, you can see the yellow marks or the white strips. In order to control the traffic, you will see these lines will be always running parallel to each other. They will never meet each other. So these are also an example for parallel lines. The fourth example is the strokes or the limbs of this ladder. They always lie parallel to each other. So these are the real life examples for parallel lines. Then we are going to the perpendicular lines. These lines intersect each other at 90 degrees. These lines intersect each other at 90 degrees. Such lines are called as perpendicular lines. So you can see that there is one line and there is another line, and they are meeting each other exactly at 90 degrees. So there is a formation of 90 degrees between the lines. Such lines are called as perpendicular lines. So these are the real life examples for perpendicular lines. So I have put the stumps. I have grounded them on a cricket ground. You can see that the stumps are exactly perpendicular to the ground. So they are making exactly 90 degrees. Will the stumps be slant or straight? Straight, right? So they are making exactly 90 degrees with the ground. The lamp post that we see in front of our house, which will light exactly at 6:37 only for few days, and until unless we call the electric what it is? KV. Unless until we call again, they will be there for 1 month. So those lamps will also be making a perpendicular angle. So you can see that it is making a perpendicular angle, 90 degree angle with the ground. So this is an example for perpendicular. Also you can see the corner of the door. So what is happening? There is one wall, there is another wall. They are coming and meeting at 90 degree. We can also observe this particular corner of this pillar. So one line, the one wall, other wall of this sides of this pillar, they are coming and meeting at what angle? 90 degree. Yes. Can we give them as an example for perpendicular lines? Yes. So this is the third example. The legs of the chair. So this is the platform to sit on the chair, and these are the legs. So this platform is making exactly 90 degrees with the legs of the chair. So again, what you can say, those lines are also perpendicular lines. One more example that lies in our class is this: the frames of this blackboard. So one line is traveling in the x-axis, y-axis, z-axis. One more is traveling in the x-axis. They are exactly making a 90 degree. So these are also what?
Legs of the legs.
Yes, exactly. So these are all legs, everything. You can see they are making a 90 degree angle. Next. Then we will be going with a couple of questions. I will answer a couple of questions. They are simple, right? So what do you mean by line segment, guys? Yes.
The line which has fixed distance is called as line segment.
Yes, exactly. Very good. So the line which has got a fixed distance is called as line segment. Next. How do you distinguish a line from a line segment? I gave an example of the serial and everything. I said about the segment. I said about the slabs, the upper slab and line both sides. Fixed lines. Exactly. Very good. So, as you said, line can be extended on both sides. It doesn't have any fixed line. Whereas line segment has got a particular fixed distance. What do you mean by intersecting lines? They meet at a particular point. The lines which meet each other at a particular point are called as intersecting lines. What do you mean by parallel lines? Just shoot.
The lines which never meet.
The lines which never meet are called as parallel lines. Exactly. Next. What do you mean by perpendicular lines?
The lines which are exactly 90 degrees.
Yes. The lines which meet each other at exactly 90 degrees are called as perpendicular lines. Next. So this is one of the lessons. Ma'am, second step. 12-15 hours ಮುಗಿಸ್ಬೇಕು ನಾವು ಗೊತ್ತಿಲ್ಲ ಕಂಟೆಂಟ್ ಹಾಂ Friends, we have got two walls over here, right? These two walls come and meet at a particular point. What do we call this as? The word starts with C. Corner, exactly. So, when two lines or two sides or anything as such come and meet each other, there is a formation of a corner. We always say corner, right? Corner table. Nowadays there is a new trend that is starting. That is, we will be having the corner tables so that the corner doesn't look vacant. Nowadays we will be having a corner tables. It will be like this fashion, so that the space is utilized. We can keep the vase, flower vase, and other materials that are required. At the same time, the corner won't look odd because the vacant space. So there is a function of corner. In mathematics, we call such corners as angles. So that is the simple terms we can understand what you mean by angles. Then in this module, we will be learning about what do you mean by angles. We will understand the concept of angle. We will also look at the parts of angles. We will see as we got different parts of human being. In the similar fashion, an angle also has got its own parts. So we will be looking into that. Then we will be understanding the different types of angles. And finally, we will be seeing the real life examples of angles. So first, what do you mean by angle? So as I initially said, angle is a corner that is formed by two lines or two surfaces. So it is basically measured in degrees. So what is the angle that is formed at the corner of that wall? Can you tell me? What is the angle? What is the angle that is formed here? 90 degree, exactly. So you said 90 degree. I didn't say you in which unit you will measure. You directly said 90. You didn't say just 90. You said degree. So degree is the unit to measure the angles. So in the similar fashion, you got OA and OB are raised. Yesterday, someone was dealing with the angles and they were discussing about the ray, right? Yes. So we are discussing about the ray. So this is OA is a ray, OB is also a ray, and there is an angle that is formed between these two rays. and this corner is what? It is an angle. So this is the real life example for angles. So the angle between the hands of clock. One we got the hour clock. The second one is the minutes clock. So it's roughly about 3:10, right? So the clock is showing the time 3:10. So you can see that the two hands of this clock are making particular angle. So we can say it as an angle. So I was talking about the corner table, right? The decorative items kept at the corner. So this is an example for that. So what the people are doing is they are placing these kind of tables at the corner and they are putting books or various items so that it looks nice. Whenever someone comes to our house, it looks attractive, it looks decorative. So this is an angle that is formed between the walls. This is one wall, this is the second wall. There is an angle formed between these two walls. Now we will understand what are the different parts of angles. Basically there are three parts. OA and OB are the two rays. Rays which initiate from one point and they are extended unlimited. So such lines are called as rays. If the line can be extended, if a line segment can be extended on both sides, then we say it as a line. If it is extended only on one side and if the other side is kept fixed, then we say it as a ray. For example, sunlight. So we never say sun, when we are talking about the sunlight, we always say the rays of sun, the rays, sunlight rays. So why do we call it as a ray? Why don't we call it as a line? It is because sun is at a fixed point. Rays are coming, the lines are coming out of it. From a fixed point, they are reaching our earth. If there was no earth, then it would have accelerated in a simple fashion. So there was no limit for the other end. So that's the reason we always say rays, gamma rays, X-rays. So these are all the rays because they are coming from fixed source. There is a generation of the source of rays and then it will be bombarded on other material. So that is an example. That is a simple example of rays. So you got two rays, OA and OB, and these two rays are separated by a corner, an angle, say angle theta. So O is a vertex. Vertex is nothing but the point where two lines come and meet each other. So one ray and another ray, they are coming and meeting at a particular point. This is called as vertex. What is the plural form of vertex? Do anyone know? What is the vertex means one, singular. If I have two vertices, then what do you call it as?
Vertices.
Vertices, exactly. So it's the vertices is the plural form of vertex. So theta is the angle. So angle between these two rays. So these are the parts of angles. Now we will understand what do you mean by acute angle. It's a acute angle, right? So the angle, it will measure less than 90 degree and greater than 0 degree. The angle will be greater than, it will be less than 90 degree and it will be greater than 0 degree. When I am talking about the angles, if you are saying acute angle, then it will not have any feel. You should have the feeling when you are saying the words. Acute angle. So that feel should come when you are saying that word. When you are pronouncing, the feel should come. Only then you will understand. Okay, it is small angle, acute angle, right angle, obtuse angle. When you enjoy, when you start feeling those words, then you will get the literal meaning of those words. Acute angle, small angle. So the angle is measures less than 90 degrees. Such angles are called as acute angles. So examples for them are 30 degree, 45 degree, 60 degree. These all lie within the range of 0 to 90 degrees. Such angles are called as acute angles. So in that diagram, you can observe that what is the angle measured there? 30 degrees. So whether it is lying within the range or not? Yes or no? Yes. So we can say it as an acute angle. Next. So these are the real life examples for acute angles. I have brought a pair of tongs. So these are used in kitchen when we will be soaking, when we will be baking the roti, when we want to do pulka roti, something they will be calling. Exactly, I am not knowing the name. So when you are doing that, we will be holding it with the tongs and we will be just shaking it on the fire. So that angle what is formed, that is basically an acute angle. That is small angle. In a simpler fashion, the angle that is formed between the scissors, the pairs of scissors, you can see that is also an acute angle. The angle formed between the compass needle and the pencil holder, that is also making the angle less than 90 degrees. So we can give it an example as acute angle. Then it comes to the right angle. Right angle. Right angle is the angle which is equal to 90 degree. Angle which measures 90 degrees for a right angle. In this diagram you can see that. So these are basically the perpendicular lines, right? One line, the other line, they are meeting each other by forming an angle 90 degree. Such lines are called as perpendicular lines, and the angle formed is right angle. So as we discussed the initial examples in the previous slide, also we discussed the same examples. So you can see that there is a formation of 90 degree angle over here. The sums is making a 90 degree with the ground. In a similar fashion, the lamp post is making 90 degree with the ground. So these are the real life examples for 90 degree. In the third example, you can see that there is a famous watch that is present in the tower. It is located in London. So in the clock, you can see that it is exactly 3 o'clock. So it is banging 3 o'clock. So you can see that the minutes and hours, they are making an angle 90 degree. They are exactly sharply they are making a 90 degree angle. So these are the real life examples for right angles. Then we are coming to the obtuse angle. Obtuse angle. So the angle which measures more than 90 degree but less than 180 degree. So we are putting the range now. 90. Initially for acute we took the range as 0 to 90. Now we are taking the range as 90 to 180. So if the angle is measuring more than 90 degree but less than 180 degree, then such angles are called as obtuse angles. So examples are 130, 145, 160, so and so forth. So that is the diagram to demonstrate the obtuse angle. You can see that the angle is measuring exactly 90 degree. So where is the 90 degree? It is somewhere here, right? It is somewhere here. This is the 90 degree. So the angle is beyond 90 degree. But also you can see that if this is the 180 degree, then it is less than 180. So it is less than 180 but greater than 90. That's the reason we call it as obtuse angle. So these are the
ये मारो नोट के क्लास कैसे होता है
these are the examples for obtuse angles. So I put the Laplace figure. So you can see that the rubber that is open over there. So it is making an obtuse angle. So initially if I take this is a right angle. This is a acute angle. If I just bring it back, then what is happening? It is forming an obtuse angle. So this is an example for obtuse angle. Then we got the arm shape, right? So that is also forming an angle greater than 90 degrees. So you can see that there is a slant backward and that is forming a angle greater than 90 degrees. So this is a real example for obtuse angle. Then you got the straight angles. The angles which measures angle equal to 180 degree. Such angles are called as straight angles. Straight. So you can see that the arm is straight. So you can see there is a 180 degree angle formation. In the diagram we can see that the angle formed is exactly 180 degree. Next. So you can see the examples, right? The pole where we put towel or the dressing table we got sitting. You can see that the angle formed is exactly 180. It is a straight line. So this is an example for 180. And the base of the staircase. So it is forming an angle how much? 180 degree. Yes. So it is an example for straight line. If the clock bangs 6 o'clock, then you will see that the hour clock and the minutes clock hand, they are straight, exactly straight. So you can see that there is a formation of 180 degrees. So all these three angles, which are demonstrated in the figures are called as straight angles. Exactly. Next. Then we are talking about the reflex angles. Reflex. The angles which are measuring greater than 90 degree but are less than 360 degree are called as reflex angles. For example, 230, 345, 260. All these are the examples for reflex angles. So you might have heard the word reflex when you are talking about the cricket commentaries. The fielder has a best reflex. For example, Ravindra Jadeja or many other fielders who are good at field, they will be always says that the fielder has a good reflex. That is, suddenly he will be able to jump and catch the ball when he is standing in the slip or in the gully in the point. So or in the cover. So you can see that they will be having a good reflex. So because they were able to bend their body to a greater angles. So that's an example of reflex angle. So these are the real examples for reflex angles. You can see if I cut a slice of pizza, then the remaining part of this slice, the remaining part of this pizza is greater than 90 degree, but it is not. But it should be always less than 360 because I am doing this particular part. So some angles is removed. So it will be greater than 90, but it is less than 360. Such angles are examples of the reflex angle. Now if I got 9 o'clock on the clock, then you can see that the angle formed is exactly 270 degree. So you got 90 degree minus, so it will be 270 degree. So it is also an example for reflex angle. This is a Japanese fan. So this example actually I got it from the first day when Sunitama was giving the example for lines and angles. She was demonstrating. She was talking about the Japanese fan. So you can see that the angle is greater than 180. So if I just take this scale or rod, what you can observe is it is forming 180 here, but we got certain angle beyond this stick. That means it is greater than 180. So hence it is called as reflex angle. Next. So this is the final, that is the complete angle. So we are going to complete the ICT lesson. So that is the reason I have to take last. Complete angle, to complete the things. So angle which measures equal to 360. There is one player in cricket who is called Mr. 360. Do you know who he is? A.B.D. Yes. So he can hit the shots all over the park. He can hit it, he can loft and take it over the third man, point fielder, over the mid wicket, mid on, over the fine leg. In entire regions, in all parts of the ground, he can hit the shots. That's the reason he is called a complete player and he is called a 360 degree player. In the similar fashion, the angle which is making 360 degree complete angle, then we say such angles as called as complete angles. It means which is equal to 360 degree. So these are the examples. As soon as we have got the 31st December, what it is the 31st December, what it will be? New Year, right?
New Year.
We will be eagerly waiting for 31st December night 12 o'clock. So that is the complete angle. The minutes and hours both are overlapping over each other. So there is no angle, there is no gap. So both are completing the entire rotation and coming to their original point. So it is measuring 360 degree. In the similar fashion, the wheel that we use. So those are also constantly revolving around this particular axis. So it is also forming a 360 degree, right? So we are having a couple of questions, right? First one, what do you mean by angle? Yes. Can you define what you mean by angle? Yes.
Angle is a corner formed by two lines.
Yes, exactly. Angle is a corner formed by two lines, not two rays. So can you name any 4 types of angles? So I discussed so many 7 angles, right? A, B, C, D, F, G, H, F. So 7 angles are discussed. Yes. So I asked what she said 5. Thank you so much. So these are the different kinds of angles that are present, right? Next, which type of angle is depicted in this figure? So you can see that.
Yes.
Reflex angle.
Obtuse angle.
Check clearly. How much is it? Obtuse angle, right? So it is forming an angle greater than 90 degree, but it will be less than 180. So this is an example for obtuse angle. Yes, exactly, correct. So give an example for acute angle in your real life. What are you seeing around you?
A slice of pizza.
Slice of pizza.
Pizza.
Or yes, exactly.
A slice of roti.
Slice of
Roti.
slice of protein.
Roti.
Roti, yes. Those are the samosa something.
A slice of birthday cake.
Birthday cakes, yeah, exactly. So those are all the examples for acute anger. So I have put one example as slice of pizza bread. So thank you guys, thank you madam for giving me a answer. Thank you very much.
Yes. Yes. You know, what they are not